So we're going to go over powers first. So what is a power? Well, it's just a number that's in an exponent, right? So the word power kind of means the same thing as exponent. So we're going to study powers before we go to solving these equations. First of all, I want to look at, no, I don't want to look at powers of 0. Let's look at powers of 2 first. Then we'll talk about powers of 0. Powers of 2. I'm going to start with some things that are more familiar, and then meaning positive exponents, positive powers, and then we'll talk about the negative ones. Okay, let's start all the way to the right here. 2 to the 6th, right? What does that mean? That means 2 times 2 times 2, 6 times. 64, okay? 2 to the 5th, 2 times itself 5 times. 32. 2 to the 4th, 2 times 2 times 2 times 2 is 16. By the way, just an interesting thing in math that I picked up on one day. The only equation where you can flip the base and the exponent and they equal each other is when 2 to the 4th equals 4 to the 2. Can't do that with any other numbers. In other words, you can't flip the base and the exponent and make them equal. Of course, 1 to the 1, right? But 1 to the 1 and 1 are the same number, so the only time where that happens. Anyway, 2 cubed is 8. 2 times 2 times 2. 2 squared is 4. 2 to the 1st is 2. Anything to the first power is itself. Does everybody understand that? Because you're not multiplying it like by itself. You're just leaving it that way. So now I want to talk about to the 0 power. Can everybody see that as you move to the right in this little chart, everything is multiplied by 2? Makes sense, right? You're increasing the power. So to get from 8 to 16, I multiply by 2, right? The reverse is true. When you move to the left, you divide by 2. To go from 2 to the 6th to the 5th, divide 64 divided by 2, right? 32 divided by 2 is 16. And so for this reason, when we get into negative exponents, you just divide by 2. You're dividing 2 to the 0 divided by 2 gives you 1/2, okay? Another way to think of it as 2 to the negative 1 is the same as 1 over 2 to the 1st, which is just 1/2. So it's as simple as when you move to the left, you divide by 2. When you move to the right, you multiply by 2. As these powers increase or decrease by 1. So that means 2 to the negative 2 would be taking this and dividing that by 2. And you can also see some symmetry here. Notice how 2 to the negative 1 is 1/2, 2 to the 1st is 2. The same is true over here. 2 squared is 4, 2 to the negative 2 is 1/4. So if you know 2 squared, all you have to do is put it under 1. 2 cubed is 8. The reciprocal of that is 1/8, which is 2 to the negative 3. And then finally, I just stopped at 2 to the negative 4, which is 1 over 16. You could obviously do, and let me quiz you guys. What would 2 to the negative 6 be? 1/64. You just take whatever 2 to the 6 is and you write it under 1. And of course, there's more powers. 2 to the 7th is 128. Multiply that by 2. The biggest you would need to know, I would think, is 2 to the 10th, which is 1024. Obviously, you can just keep doubling these numbers, and they're going to get bigger and bigger. Those are powers of 2. That's where they come from. Any questions on that? Okay, let's look at powers of 3. Don't need to know as many, because 3 gets obviously bigger. 3 gets bigger, obviously, as you multiply it, because it's a bigger base. That's what we've been talking about, right? The bigger the base, the faster it grows. We'll just start at 3 to the 1st, right? We know it's itself. It's 3. 3 squared is 3 times 3 is 9. 3 cubed, 27. 3 to the 4th, 81. 3 to the 5th, 3 times 3 times 3 times 3 times 3. This is definitely the biggest you need to know, 3 to the 6th, just because after that becomes a 4-digit number, and I don't know what that is myself. But I do know that sometimes these numbers come up. For example, they just came up in Algebra 2. So then, again, anything to the 0 power is 1, except for 0. We'll talk about that. And then again, you can see the symmetry between 3 to the first and 3 to the negative 1. There's symmetry between 3 squared and 3 to the negative 2. Symmetry between 3 cubed and 3 negative 3. You're just taking whatever that is and putting it under 1. So the negative powers are easy. They're just 1 over whatever the positive powers are. And so, yes, if you take a number, a whole number, and you raise it to a negative power, you do get a fraction back. Will you ever get 0? No, right? We talked about the fact that exponential function does not have any x-intercepts. This fraction will get smaller and closer to 0, but it'll never reach 0. Yes?
Does that also mean
The thing I want to do is bring up powers of 1, which, does anybody know, like, why that's so trivial?
because 1 is 1.
Yeah, 1 to any power is 1, okay?
What about 0?
Still 1. So, for powers of 1, you don't have to write all this down. You can literally just write any 1 to any power is 1. You can see why here, okay? No matter how many times you multiply 1, you get 1. No matter how many times you divide by 1, you get 1. It's the trivial thing, right? Any power of 1 is 1. Now, the reason I'm going down to 1 is because I want to talk about 0, right? So we went from 3 to 2 to 1. Next, we'll look at 0. So bear with me as I explain powers of 0. Now, obviously, when you multiply 0, no matter how many times you multiply 0, you get 0 back, right? So let's just start with the obvious. 0 cubed would be 0 times 0 times 0, which is 0. 0 squared would be 0 times 0, which is 0. 0 to the first would be 0. 0 divided by 0. So if you notice something here, let me go back to these other numbers. Yeah. When you raise something to the 0 power, it's the equivalent as dividing by itself. We can see that when we look at our basis here, because you're taking whatever it is to the first and dividing by itself to get 1. So that's why anything that's not 0 to the 0 power is 1, because you're dividing by itself. So anything to the 0 power means you're dividing by itself. So the real question is, what is 0 divided by 0?
0. Or is it 1?
I'm going to go down here.
Any number.
Yeah, I'm going to explain why it's any number. It's 0 divided by 0. Let's just write 0 over 0 equals x, meaning we don't know what the number is. Okay, so I want to explain this a little bit better. Let's set up another division problem right here. 12 divided by 3 equals 4, right? And so you can turn any division problem into a multiplication problem. Meaning, take your answer, multiply by the denominator to get the numerator. 4 times 3 gives you 12. Well, think about this. What number times 0 gives you 0? Any number. So 0 over 0 is actually any number. Another way you can say it is undefined. Undefined because any number means there's no definite answer. So if I go into my calculator and type in not that. Let's just go down here. If I type in 0 divided by 0, it says undefined, meaning there's no definite answer. Any number will work if you look at it as a multiplication problem, meaning x times 0 gives you 0. So pretty much any number you'll get back, or you could get back. It's a little bit more complicated that when you start studying calculus and stuff and limits, but basically, you can just write any number undefined. Now, the problem when you do 0 to a negative power, though, is you're taking that any number and dividing by 0. So if you take any number that's not 0, so let's say the number's 4, and divide by 0, well, that becomes a problem. You can't take a non-zero and divide by 0 because, let's write this as x again. Okay. The reality is there's no number that when I multiply it back to 0 will give me 4. It won't work, right? So if the numerator is not 0, that's why you get undefined. No solution. So 0 to a negative power is going to be no solution. It's more complicated than that when you think about, well, what if the numerator is 0 again? But let's just focus on this part, no solution. No solution to the negative power. 0 to the 0, you can just write undefined or any number. And 0 to a positive power is 0. And so that's basically it for powers that you need to know. Powers of 0, 1, 2, and 3. You might need to know, I mean, obviously 4 squared is 16, 4 cubed is 64. Those might come up sometimes, but the ones that come up the most are 2, 3, sometimes 1, sometimes 0. I'm going to give you guys maybe 5 or 10 minutes to study these, and then I'll come back and we'll do some examples on solving exponential equations, which requires knowing these powers.